Hello, Trinity. This video is for you if you missed class on April the 25th or April the 28th. This is also for you if you're confused and you need a reminder of what we did on that day. You should have this in your notes if you were in school on those days. If not, you need to go ahead and copy these notes, please. We're talking about stoichiometry and what it means. Your basic definition is that it's just a comparison of two different substances in a chemical reaction. So I have an example here for you so you understand what that definition means. You'll see the reaction here that is the synthesis of water, and it is a balanced chemical equation. When we balanced chemical equations before, when you first learned how to do this, when we read the chemical equation, we would read that as 2 units of hydrogen plus, if there's no coefficient, it means 1 unit of oxygen gas yields 2 units of water. Now we're going to go ahead and define what that unit is. That unit that we were referring to is actually the mole. So now instead of reading this as 2 units, we're going to replace the word unit with the actual unit, which is mole. So now we would read this as 2 moles of hydrogen gas and 1 mole of oxygen gas yields 2 moles of water. Stoichiometry is just comparing 2 of the substances in a chemical reaction. Doesn't matter right now while you're thinking about it. Doesn't matter which 2 we're talking about. You can compare hydrogen and oxygen and water, or hydrogen and water. It's just comparing 2 different substances. And so the way that looks when we're doing stoichiometry is it looks something like this. If we want to compare hydrogen and oxygen, we say 2 moles of hydrogen because we have 2 moles of hydrogen, or for every 2 moles of hydrogen, there is 1 mole of oxygen. Okay, so there's our comparison. For every 2 moles of hydrogen, there's 1 mole of oxygen. And again, I got that from the chemical equation and the coefficients that are placed in front of each substance. We could also invert that. It's the same thing, but in this case, we would read that for every 1 mole of oxygen, there are 2 moles of hydrogen. And that's the basis of stoichiometry. What you should be asking yourself is why, why would we need to do that? And the answer is, it helps you determine how much product you're going to produce or how much reactant you need in order to produce a certain amount of product. So it tells how much. Okay, now that tells how much, maybe how much product you're going to produce, or it could be how much reactant that you need. Okay, so this is a definition, this is what it does, and this is why we do it, what we're going to get from it, or what it tells us. I need you to turn your textbook to page 325. We're going to work a couple of problems in here. Hopefully you already have one example of a problem in your notes already, and this would be your second. I'm looking at number 16 on page 325. I'm going to let you go ahead and read through it. Please stop the video, read through it, and figure out what you need to do, and then come back to the video. It asks you to take a word equation and then write a chemical equation from that word equation. So again, we're on page 325, and I'm looking at number 16. When you write your equation from your word equation, your chemical equation from your word equation, it says that we have sulfur dioxide and we have oxygen gas. You have to remember that oxygen's diatomic. So when you write that, it should look like that. And it says, and we have water. And that's going to form sulfuric acid. And it gives you the formula for sulfuric acid. It's H2SO4. Okay. It's then going to ask you in that question to go ahead and balance that. Now, when you balance this, you have to show me your work. So don't forget, you're going to make a list of all your elements. You're going to do your initial count. You're going to start placing coefficients, and then you're going to recount until you get it balanced. Just as a hint, place your first coefficient here. So once you get your original count, it's going to look like it's going to be impossible to balance, but it's easily doable if you start here. Okay, go ahead and shut off the video and try to balance that, and then come back to it when you're done. Okay, I'm not going to show my work here, but you should have your work shown in your notes. The balanced chemical equation will have a coefficient 2 here in front of your sulfur dioxide. You'll have a coefficient 2 here on your reactant side in front of your water, and you'll have a coefficient 2 here on the product side in front of your sulfuric acid. Okay. Before you can ever do stoichiometry problems, you have to have a balanced equation. So that's the first thing that you always have to look at. Okay, now I do like to go up to this equation, and I like to put a box around the 2 different substances that are involved in the question. One of the things that is involved in the question is sulfur dioxide. And what they did was they told us how much we had of that. So this is our reactant. And if you read back through the question, it says that we have 2.50 grams of that. Okay, so I'm just going to note that. And then it's asking us to figure out how much of this is going to be made. And so it wants to know how many grams of this will be produced if we start with this much sulfur dioxide. Okay, so as always, when we set up our mathematical equation, we're going to start with writing what we know. So we know that we have 2.50 grams of SO2. There's only 2 rules here, okay? Of course, you're going to have to remember all the rules that go along with converting units. So you have to remember how to convert from moles to grams, and grams to moles, and grams to atoms, etc. Okay. But when we're doing these problems now, here are your rules. Number 1, the unit that you're working with has to be moles. So that's the very first rule. And your second rule is going to be that you're going to compare 2 substances. You need to write these rules down. We're going to refer back to these every single time. You need to memorize these rules before we take our quiz, which is going to be your very next class. Okay, so we go back to our equation. We write what we know, and then we go back and we look at our rule. And the rule says the unit needs to be moles. Well, it's not. Okay, our unit is grams. But we know how to convert grams to moles. Okay, in order to do that, you set up a conversion factor, and you put the molar mass of this substance into your conversion factor. Okay, so when you do that, you'll get, in the denominator, you'll have 64.064 grams of sulfur dioxide. And in the numerator, you'll have a mole of sulfur dioxide. And that's a review. You should know how to do that now. You stop now and you see if you have units that cancel. And you do. Grams of sulfur dioxide canceled with grams of sulfur dioxide. And then you evaluate where you're at. So I'll look at my equation and I'm like, okay, now what are my units? My units now are mole of sulfur dioxide, mole of SO2. Okay, so I'll go back to my rules. Rule number 1, the unit has to be moles. Yep, check mark. That's done. So now I'll go to rule number 2. Rule number 2 says compare 2 substances. So remember, we just learned how to do that. You'll set up another conversion factor there, and we're going to compare these 2 substances. Okay. Since I want to solve for that, that'll have to be in the numerator. So remember that 2 means 2 moles. So we'll put 2 mole of H2SO4 in the numerator. This is 2 mole. This is going to go in the denominator. 2 mole of SO2. Okay. Again, I knew I was going to put this in the numerator because that's what I'm solving for in the end. I need to know how much of that's produced. I know I'm going to put this in the denominator because I have mole of SO2 in this numerator, which means mole of SO2 would have to go in that denominator in order to get those to cancel. Cancel your units. You stop and you evaluate. My unit now is mole of H2SO4 or sulfuric acid. But my question wants grams. It doesn't want moles. So, do you know how to convert from moles to grams? Yes, you do. In order to convert from moles to grams, you need to know the molar mass of the sulfuric acid. So you take a minute to calculate that. Please stop the video and calculate that. Okay, and you would have gotten 98.078 grams per mole when you did the molar mass of sulfuric acid. Your mole of sulfuric acid and your mole of sulfuric acid will cancel out, and then you just evaluate again. Okay, so you look up here and you go, what unit am I in? I am in grams of sulfuric acid. Is that what I'm supposed to be solving for? Yes, it is. I'm good. I'm done now. I've done what I need to do. I just need to plug this into my calculator. Always start on the left when you're plugging this into your calculator. That's 2.50 divided by 64.064 times 2 divided by 2 times 98.078. And when you plug all that in, you're going to get a 3.83 grams of H2SO4. So how much H2SO4 or sulfuric acid will we produce? 3.83 grams of it. Okay, we're going to do one more example. Okay, let's do page 322. If you'll go to page 322, let's do number 13. Okay, when you read number 13, it's going to ask you again to write a chemical equation and balance it. I'm going to go ahead and do that on the board. You should turn off the video and see if you can write this yourself, because you're going to have to be able to do these. What you have to remember here is that chlorine is diatomic, so when you get to chlorine, it should be Cl2. Then I want you to balance it. So go through your process, turn off the video, balance it. I'm going to go ahead and place the coefficients myself. You'll see where they are when you come back to the video and to see if you did it correctly. Okay, this is now balanced. Again, you should have shown your work, so you should have listed out each element underneath there. You should have your initial count, and then you should have recounted on that. On this one, the two substances that are in this question are the sodium chloride, and this is what we know something about, and what they told us that we have 2.50 mole of that, and what they're asking us to calculate is how many grams will be produced of this chlorine gas. Okay, so again, we start exactly the same way as we always do. We write what we know. We know that we have 2.50 mole of sodium chloride. Okay, and then you set up a conversion factor. Okay, let's go back to our rules. The rules say that the units have to be in moles. So I'll look and see what I wrote. My unit is in mole. Check. That part is done. Okay, now on the last one, remember we started with grams and we had to convert to moles. We don't have to on this one. We are already in mole. So check, done. I'm on to number 2 now. Number 2 says compare the two substances. Well, those are my two substances. Okay, and I know that from the question that was written in words in the textbook. You have to read that question to know this. So I'm going to compare these two and I'm going to put them in this proportion. That's going in the numerator because that's what I'm solving for. This is going in the denominator because I'm not going to need that anymore. I want it to go away. If there's no coefficient there, there's 1 mole. So in the numerator, you'll put 1 mole Cl2. And in the denominator, you'll put 2 mole of NaCl. Again, that would read, for every mole of chlorine gas, there are 2 moles of sodium chloride. You should have units that cancel, and you do. Mole of sodium chloride cancels with mole of sodium chloride. You stop and you evaluate. What is my unit now? My unit now is mole of chlorine gas. Is that what I need? I go in my question. Nope. I need grams of chlorine gas. Okay, so now you have to convert moles of chlorine gas to grams of chlorine gas, and you know how to do that. You got to find the molar mass, and you need to plug it in here. So we have Cl2, so you find chlorine on your periodic table. You, again, will have to multiply that by 2 because you have 2 chlorines, right? And you'll find that your molar mass of Cl2 is 70.906 grams of chlorine per mole of chlorine. You should have units that cancel, and we do. Mole of chlorine cancels with mole of chlorine, and you stop and evaluate. Now my unit is grams of chlorine gas. What am I solving for? Oh, I'm solving for grams of chlorine gas, so I'm good. I can stop now and plug all this into my calculator. So again, start from the left. Start here. You plug that in. You multiply by 1. You divide by 2. You multiply by 70.906, and you should get 88.6 grams of chlorine. And that is stoichiometry. It is a way for you to predict how much product you're going to get if you know how much reactant you start with. Or it's a way for you to figure out how much reactant you need to start with if you know how much product you want to make. There's a PowerPoint posted on Rockspace along with solutions to textbook work, including solutions to this and other textbook work. You have a quiz when you return.